Welcome to the TOEFL listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor, or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Dr. Martinez. Thanks for meeting with me during office hours. I wanted to get your advice about sampling bias in my thesis survey.
Hi, Alex. No problem. Tell me briefly what your study is and where you think sampling bias might be happening.
I am studying commuting choices in the city. I collected responses at commuter rail stations during morning rush hour because it was efficient, but now I am worried that my sample overrepresents rail commuters and underrepresents drivers, cyclists, and remote workers.
That sounds like a classic selection bias caused by where and when you sampled the population. Your sampling frame excluded people who do not use rail or who commute at other times.
Exactly. I kept thinking that a larger sample would solve the problem, but a colleague said increasing size does not fix coverage issues. Is that right?
Correct. Increasing sample size reduces sampling variance, but it does not correct systematic bias from a non-representative sampling frame. If a segment of the population had zero or very low probability of selection, then they remain undercovered regardless of sample size.
So should I redesign the data collection to include roadside intercepts and online recruitment, or is there a way to correct the bias post-hoc?
Both strategies are possible. You should ideally redesign to use probability-based methods or a mixed-mode approach to expand coverage. For existing data, you can try diagnostic checks and weighting adjustments, but they rely on auxiliary information.
What diagnostic checks would you recommend? I compared sample demographics to census margins, and I saw fewer young adults and more middle-aged rail commuters than expected.
Comparing your sample distribution with population benchmarks is essential. It helps detect undercoverage and non-response bias. You can also look at response rates by time and location and compute design effects to see how cluster or convenience sampling inflates variance.
I also read about poststratification and raking to adjust weights. Can those techniques address the underrepresentation of young adults?
Yes, you can use post-stratification or raking to align your weighted sample margins to known population margins for age, gender, and region. That will reduce bias in estimates correlated with those variables.
But are there limitations to this approach for my commuting measures?
If your outcome, such as mode choice, is strongly related to variables you did not measure or to sampling probability itself, then weighting might not fully correct bias. Also, weights can increase variance, especially if some weights become very large.
I see, so I need good auxiliary variables and stable weights. Do you recommend oversampling minority commuter types or stratified sampling when I collect more data?
Yes, stratified sampling with oversampling of underrepresented groups like cyclists or off-peak commuters can help. You should determine strata based on known population proportions and decide inclusion probabilities accordingly.
In my initial recruitment, I used social media ads to attract participants for a follow-up survey, and I noticed many volunteers were environmentally motivated. Which bias is that?
That is volunteer bias or self-selection bias. People with strong opinions are more likely to respond to opt-in surveys. That can skew estimates of average behavior unless you have auxiliary data to reweight or you adopt probability recruitment.
How would you detect volunteer bias quantitatively?
Compare characteristics of volunteers with known benchmarks and with non-respondents if you have any information on them. You can also run sensitivity analysis. Suppose volunteers are 20% more likely to choose transit, then you can model how estimates shift under different assumed selection mechanisms.
You mentioned inverse probability weighting earlier. Can that help for non-response?
Yes, inverse probability weighting uses a model for response propensity to upweight underrepresented units. If the propensity model is correctly specified and you have predictors that explain response, then IPW can reduce bias.
What about cluster sampling, like sampling entire trains or buses? Would that introduce different concerns?
Cluster sampling is efficient for fieldwork, but it increases design effect because observations within clusters are correlated. You must account for clustering and variance estimation and ensure clusters are randomly selected to avoid selecting only certain routes or times.
If I cannot redo the full sample for the thesis, what would be a rigorous approach to report results acknowledging sampling bias?
Be transparent. Describe your sampling frame, where and when you collected data and who was excluded. Report comparisons to population benchmarks, show any discrepancies apply, weighting if appropriate, and conduct sensitivity analyses to show how conclusions change under realistic bias scenarios.
Are there quick checks that reviewers expect to see in a methods section about sampling bias?
Yes, includes sample recruitment procedures, response rates, non-response analyses, description of any auxiliary data used for weighting, and a discussion of limitations due to coverage or self-selection. Remember to report effective sample size after weighting.
One last question. If our sample underrepresents young adults, we can use post-stratification weights to adjust estimates, but that assumes the relationship between age and the outcome is the same in respondents and non-respondents.
Exactly. That assumption is important and often untestable, which is why sensitivity analysis is so useful. It shows the robustness of your conclusions when that assumption is relaxed.
Thank you. This helps a lot. I will include these diagnostics and plan a small stratified follow-up to fill gaps.
Good plan. Reach out if you want help with propensity models or computing weights and variance estimates.
I will. Thanks again.
Listen again to part of the conversation. Then answer the question.
If our sample underrepresents young adults, we can use post-stratification weights to adjust estimates, but that assumes the relationship between age and the outcome is the same in respondents and non-respondents.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.